Hello everyone. So welcome back to this channel once again, and in this video session I will discuss read a stream file randomly uh, using the LSEEK API which is available in C. So basically I'm going to use this API in our RPG program, which is going to set an offset to some position on the IFS stream file. So let me brief you something regarding reading the file randomly in RPG or in stream files in C. So we can use setll or setgt to just uh, read the file randomly or setting the pointer to some records because they are arranged in the form of records. But in an IFS stream file, they are arranged in the form of continuous stream bytes. So they don't have the records like things. So they are not arranged based upon on the records. So we cannot point to the particular record onto the stream file. So we can play with the offset in the IFS stream file. So we can either move some uh, offset forward in the IFS string file or move some offset backward from some particular point. So that particular point either would be the start point or the current point wherever you are on the uh, stream file while reading the data, or from the end. So you can move backward or forward from any position, start, current, or end. Uh, so that's what LSEEK API does. We have the prototype here in C for LSEEK API, which is it will accept the file descriptor, which is an integer, which is returned from the Open API for any file which is being opened. Then the offset, which you want to move forward or backward, means positive or negative, and then the whence, which is telling whether it's from start, it's from current position, or it's from the end position, and it will return a new offset position once it is successful, and if it is not successful, it will return -1. So let me demonstrate you the example in RPGLE program. So this one is the program. So here I used some of the APIs to demonstrate from the starting, so that one who is new get the idea how the file gets created on the IFS and how we basically open, read, or write everything. So you can see we have used close, write, open, and read API. So I'm just briefing error API and str error API. So I'm just briefing these things here. The first API is open, which is used to create a IFS file on the an stream file on the IFS, or um, you can say we can even open this file in the read mode, write mode, or any other mode which we want. So we have further parameters here: the IFS path, that is the IFS file path, the flags on which we want to open, means the mode in which we want to open, that is either read or write, or read, write both, append, or anything else. Mode is and code page are optional. This tells the authority if you want to provide to that file which is going to be created on the IFS, and this is the CCS ID for the file if you want it to be in some particular CCS ID. So this API will return me a file descriptor, and this file descriptor is further used by several APIs like close, like read, like write as an input parameter. So this file descriptor will then be telling that which file is being opened and which file you want to close. So it will return either -1 or 0, means -1 means error in closing, and 0 means successful close. Write is something where I am passing the file descriptor, the buffer which you want to write, and the number of bytes which you want to write. So it will return me the number of bytes being returned. So if it is less than the number of bytes being have to be written, then there is some error in rewriting the data on the IFS file. This will going to accept the file descriptor, the buffer where we will be receiving the data from the IFS file, and the number of bytes which we want to read. Then the error number API, which return me an error in case of any error in reading, writing, or opening a file. And this will return me the error message regarding to the that error number. So it will accept the error number which is written from this API, and this will return me the error message. So they will basically return the pointer. So I define those return pointer here, and based one is string. First one is the numeric string, and another one is the character string on those pointers. Then I'm going to use LSEEK API. So let me tell you. Um, so you can watch all my videos like open, write, read, close, so which will tell you how they are working, and the error handling thing from here. So you can watch this video as well to just get insight of the error APIs which I'm using. So now I'm going to use LSEEK. So LSEEK is the API which we are now demonstrating. So what it accepts the file descriptor. So this is the prototype in RPG, and we have this prototype in C. So it will return an integer, the new offset. It will accept the offset. It will accept the events. Events means the starting position, and this will be the offset. From this offset from the starting position we want to read further. Now these are the flags which I defined here. So basically they are values 0, 1, 2. 0 events means we want to start reading from the start, and we want the start reading from the current. This one is from end. So if we pass set, it means from start. We pass current, it means from current position. If we pass end, it means we want to read from the end position of the file. And then we will be specifying the offset, which will tell that if let's say I specify whence as set means from the starting and offset is 10, so I'm going to read the data from the 11th position because the offset is 10, so which is from starting. Okay, now if I'm on 10 and I set the I set the offset as 10, and now I set the seek underscore current while opening while reading the file. What I'm doing is I am on the current position, which is 10 offset. Now I'm going to set the offset 10 again. So 10 plus 10 is 20, so I'm going to read from 20 first. Now if I want to, if I'll be setting the end, and let's say the end would be, let's say 41 position or 40 position, and I wanna read, let's say, some last 5 bytes. So I would be setting the data, I would be moving forward, so I'm setting it in minus 5 or minus 10 or minus 12, 20, 30, 40, whatever you want, so that we can move backward, or we can read last some bytes. So these flags will be used in events parameter, which will tell whether to start from beginning or the current position or from the end position to further offset. So let me tell you, these flags are for the open API, which is going to be passed in O flag, which tells whether we want to open the file in the read, write, create, or all these things. So you can get these understandings from the videos which I mentioned earlier in the video. So this is the mode which tells the authorities. So you can get all this information from my previous videos of open, close, write, read APIs and the error APIs. These are the variables which I used. So these are the return values from different APIs: write, read, close, LC. This is the IFS data which I'm going to read or getting back from the writing to the IFS file descriptor returned from Open API, code page, mode, flag, and IFS path being used by the Open API. So what I am doing, this is actually not required here if you have already a file on the IFS. So this code is not required then. So what I am doing using this code is I am creating this LSEEK file on the IFS in. So you can see the flag is create file if not exist, means I'm going to create a file, and then I'm going to open that file in write only mode so that I can write the data. I'm providing the authority of read, write, and execute owner. So I have RWX authority on that file once it is created. So it will now I'm going to call open API that will accept the IFS path, the O flag, and the mode. And since the mode is optional, so it depends upon me if I want to pass this or not. Even CSS ID was optional, so I didn't use that one here. So if file descriptor is less than 0, which means there is some error in opening or creating that file. So then you will be calling the error number API, which will return the error number pointer, and then you pass the error number written from this API, and you will get the error message pointer, which will give you the error messages regarding to that error number. So if in case there is no issue, we'll move forward. We'll writing this IFS data onto the IFS file using the file descriptor, and this IFS data, this is the address of that variable and the size of data. So if whatever returned from here is less than the size of data, means we have write some less amount of data, so we are having some error. So we'll get that error using these APIs again. So we will call this error number or str error API to get the error number or the error message in every case. Then we will be passing the file descriptor to the close API, which will return me close. If -1, there is some error in closing, otherwise it will get closed. Now until this line we don't require this code, because this is for beginners. It is just to tell them that you will be creating or writing data to the IFS file using this if they don't have any file on the IFS till now. Now they have file on the IFS, a new file on the IFS. After that, what they will do, so the program actually starts from here. So they will open that file if they have file on the IFS. If they don't have, the above code will create the file. So now they will read that file, they will pass the IFS path, and they will pass the open flag as read only. So I'm now going to open the file in read only mode, because earlier I opened that file in write only mode and create if not exist, and then I close that file. So once the file is closed, there is no file open now. Now I'm again opening the same file in read only mode. So again checking the same thing. If a file descriptor less than 0 means opening error, and we'll call the error API to get the error message or error number. Now again clearing the IFS data, now reading. Now this is the simple read which I am to show here. So I'm passing the file descriptor, address of data, and the size of data. So this will tell me this size of data we want to read, and this IFS data will get evaluated from the or populated or retrieved from this read API once this read API is successful. If there is any error, or because we checked, you can see I'm checking read underscore read is less than 1, means we can have, this is possible that we have read all of the data in the file, and we read the end of file. So if there is less than 1 record, means we reach end of file condition, so we'll check less than 1. We are not checking whether return underscore read is less than percentage size of IFS data. It could be possible that we are reading less amount of data at a particular time, and we are reading that in loop. So I'm not going to perform that loop equation here, so you can do that at your end for learning purpose. And if any end of file is, I'm calling these error APIs to check the error, whether whatever the error is. Now the actual thing comes here, which I'm demonstrating here. This was a simple read, so here you will be reading all the data. Now I'm going to read the file randomly. Let's see. Let's focus here. So file descriptor, we are passing an offset of 10, and I'm passing seek underscore set. Seek underscore set means we are reading from the start position. So from start I am moving forward. From start I'm moving forward 10 offset, means if I am on file this, I have written, let's say I have written this data LSEEK C API 1 2 3 4 5 6. So from start 1 2 3 4 5 6 7 8 9 10. So I'm moving 10 offset forward. So the offset is 10 here. So I'm going to read from here till further size of data or whatever size I'm passing. So using LSEEK, what I'm doing, I'm setting the offset it will return me the offset. So I'm setting 10 offset from the start, so which will return me the new offset for me. So the new offset for me right now is 10, because I'm starting from the start position, from the beginning position. So if it is less than 0, means there is some error in setting the offset. So then we will calling the error APIs again to get the error message, error number. Now if this was successful, now we can read the data. So we are simply reading the data as we were reading earlier. So what I'm doing, I'm passing the file descriptor address of the data, from where I want to store the data, where I want to retrieve the data. And here I am passing, either I can pass percentage size of data, but if I pass percentage size of data, it will take from 10 to 41. 41, why I'm saying, because the variable length is of 41 here. So that would be 31 here. So we would reach to the 31, means we would reach to the last position. So in that case, I am not able to show you the current scenario, the seek underscore current, that is reading from the current position scenario. So that I have taken less amount of data reading here, as you can see. Let me come here. So you can see I'm calling seek underscore set 10. Then I am reading the data from the 10th offset till 10 length. Okay, till 10 number of bytes I want to read. So I'm going to read from 11th till 20 this time. Now if return underscore read is less than 1, the end of file reached, and we come out from here. Now you can see again, this time earlier I said the seek underscore set, which is from the starting. Now I am on 10th offset and I read 10 positions, so I am basically on 20. So from current, okay, so what I'm doing, from current I am reading 10 offset again, so I'm going to be on 20, and I'll be going to set the offset forward to the 20, so I can read from 20 to or next number of bytes. Maybe here I took percentage size of data, so I'm again going to call read. So before calling read, if I want to read the data randomly, I need to call the LSEEK API to set the offset from start position to some number, or from the current position, or from the end position. So at last you can see I'm setting the offset from the end position to -10, because I'm going to read backward here while passing the file descriptor, and then we are going to read the data till the percentage size of data. So this way you can have all these things at your end. But let me compile this so that I can show you the same thing in debug. This will let you understand the things clearly. The program is compiled successfully. Just do strdbg lseek just set the breakpoint at line number 1 and call this LSEEK API. So first thing I'm doing is I'm going to create this file. You can see this file does not exist at all at this part, and then I am opening this in write only mode and creating this file, and these are the authorities. Now I'm calling open API. File descriptor is 0, which means it is created. This is created, you can see no data. Option 9, you can see the authorities write, read and execute, which we provided when we are creating this one. Now I'm going to write this, because we opened this in write mode. As you can see, write mode. Just we are going to write this data. So we are passing the descriptor, the address of the data, size of the data. Return underscore write is 41 and size would also be 41, so it is not going to be error. Now check whether it's written or not. You can see the data has been returned to the IFS stream file. Now we are going to close this API. So we are passing the file descriptor. It will close the API. It's not -1, it's 0. It is closed. Now this was the code which I just written so that you have one file on the IFS having some data. If you have already any file and you want to read that file, you may skip this code from here, not from here, from here, because you need the IFS file name till close API, this one, and you can write the code from here. So now from here I am opening the file read only mode and I'm passing the IFS path. So this file is opened successfully. As you can see, file descriptor is 0. Now I'm going to read the data. I'm normally reading the data. I'm not reading data randomly. So currently IFS data is blank. Now it has all the data: LSEEK C API, demo in RPG AS400 program. So you can see. Now what I'm going to do is I'm going to read data randomly. So from start, I'm setting the offset to 10, and this is the file descriptor which I'm passing, and this is 0. So it will return me the offset to 10, which is not less than 0, means I have set the offset to 10 right now, and it will now I'm simply reading the data. I'm now calling the read by passing the file descriptor. IFS data is cleared here and address of IFS data, and I'm going to read 10 bytes. So from 10 I'm going to read 10 bytes. So it returns me 10 bytes and it returns me data as well, I demo in. So if I would show you I demo in, so you can see 1 2 3 4 5 6 7 8 9 10. From here 1 2 3 4 5 6 7 8 9 10. So the 10th is blank, so that's why we are seeing I demo in. So we can see the data we have read from here. Now we are going to set from the current position till the we are passing the file descriptor return SQL seek is 30. Okay, so the current position is right now, what is the current position? You have set the offset on the 10th using the earlier one, LSEEK, this one, and you read from there, you read 10 bytes. So you move forward 10 bytes from 10th position. So basically you move till 20. Now you are on 20, current position is 20, and you will be reading 10. You are moving forward 10 more bytes, 10 more offsets, which means you are setting the offset to 30. Okay, the offset is 30 here. Now you're going to read the data from 30th offset, and you will read the data till IFS size. So from 31st, whatever the data is, you will going to read that. That's 11. Oh, that's correct as well. Programming. So if I would show you this one, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. From 31 you are reading all the data, programming. Okay, so that's from the current position. Now we are setting the position on the end position, that is on 41st, and moving forward 10 forward. So the offset would be 31 here this time, because 41 minus 10, that is 31. So I'm setting the offset to 31 here, and I'm going to read from the 32nd till whatever the size of the data. So whatever data it has forward, we will be reading that. So now IFS data programming, from 31 is the offset, so we're going to read the data from 32. So we are 30 is here and 31st is here. So we are reading data from 32 till whatever the size of data, whatever left. So here you get programming. So that's what the aim is. So you read the data. This way you use the LSEEK API with the read API, so that you would be able to read the data randomly from different positions to different offsets. So now you have the I think you have now the command over this reading and stream file randomly from any position or whatever offset you want to read. So this way you will be easily able to tackle these things. And that's all in this video. Thank you and have a nice time.